Oh, good afternoon, everybody. Happy Tuesday. Happy Tuesday. I think almost everybody's here. So last class we were looking at phosphorus. Today we're going to look at water. Most of you have done the AP classroom for water already. So we're going to look at that. And then I'm going to do our cues for both phosphorus and water. I'm going to give it a second, wait for a couple more people to come in, but this is where we're going to start. So, like I said, up to now, in the AP classroom, you have phosphorus and water were the last two assignments. Last time I checked, most of you hadn't finished, had not finished water, and a couple of you still need to do phosphorus. So we're going to watch Mr. Sneed's presentation for the hydrolytic cycle. Again, hydro means water. And then I'll give you a chance to catch up on the AP classroom, and I will post the FRQ. So on the FRQ that he's going to have at the end of this one, and I'll put it together with the FRQ from the last one, and I'll post that. It's not posted yet, so don't look for it, but it will be. I also want to say that, a reminder, I'll probably have to say it again, because like I said, everybody's not here. 6th period exams are on Tuesday, um, September 30th. So there will be a 9-week exam. The 9-week exam is going to be in the AP classroom. It's set up so that it has both multiple choice and written answer questions. So it'll be in the AP classroom and scored in the AP classroom. And because it has written answers, it takes me more than a minute to go in and grade those parts. But so you won't get an automatic grade because it can't be graded until the the FRQs are answered or graded, I should say. And I will do that as quickly as possible so that by the end of the week, that should be scored. But I also want to say while we're waiting for folks to come in is that anything that's outstanding, so if you're missing an assignment, the end of 9 weeks is the end of 9 weeks. So you have to get those missing assignments done before October 3rd because the grade book closes and then I can't go back and deal with those assignments. So if you want credit, if you want to get rid of some zeros, then you need to have them turned in before October the 3rd. If it's an assignment that needs to be reopened, let me know. Tutorials are Tuesday today, 1:30 to 2, and Friday, 1:30 to 2. So if you need to get with me to open something or work on something, please let me know. Okay. All right. Well, anybody who's not here is definitely late, so we're going to go ahead and get started. So again, we're going to watch water, and then I will let you catch up on anything in the AP classroom that you need to catch up on while I post the FRQs.
Covering topic 1.7, which is the hydrologic or water cycle. Just like in all of the other biogeochemical cycles we've covered, we'll be looking at how water moves between sources and sinks. Our objective for the water cycle is to be able to explain the steps and reservoir interactions in the cycle. And at the end of the video, we'll practice the scientific skill of explaining differences between environmental concepts using a visual model. So the hydrologic cycle is the movement of water in different states between different sources and reservoirs. And so in this cycle, we like to focus on, first of all, what state of matter that water is traveling in, whether that's solid, liquid, or gas, but then also where is the water moving? So what reservoir is it leaving and what reservoir is it entering? So for example, we could look at precipitation, which we probably know already as rain. And that is going to be water moving from a gas in the atmosphere as it condenses together into clouds and then eventually falls back down to Earth as a liquid. So the reservoir it's leaving is the atmosphere, and the reservoir it's entering is a little bit trickier. It's going to be hitting Earth's surface, and it could run off into a body of water. Then it would be entering what we would call a surface water or a body of water, or it could infiltrate into the ground, and it could become groundwater. So those are the two reservoirs water might be moving to. Really important to know that the hydrologic cycle is driven by energy from the sun. This is kind of a tricky concept, but think about a body of water. As the sun hits that body of water, that's going to cause the water at the surface to warm and eventually turn into a gas and evaporate. The largest reservoir of water on Earth is the ocean. That's important to know. But two smaller reservoirs are polar ice caps, glaciers, and ice caps found on mountains, as well as groundwater. These are very important because they're freshwater sources. So humans can't use salt water from the ocean for things like agriculture or drinking, but we can use these freshwater sources. So even though they're a lot smaller, it's really important that we remember these are our key freshwater sources. Now we'll talk about evaporation and evapotranspiration. So these are the two key sources or processes that move water from a liquid form on Earth into a gas form in the atmosphere. Sometimes we call this the vaporization of water because it's liquid water transforming into a vapor or gas that enters the atmosphere. So transpiration is this process where plants are going to draw water up from the ground via their roots and up into their stem and their leaves and other places in the plant that need water. So they do this with a really neat trick. And they are going to use these little pores in their leaves called stomata. So the stomata open up. So if we look at the diagram here, we can see these pores basically in the leaf are going to open, and water vapor is going to evaporate due to the sun's energy. What that does is creates a low pressure system where the leaf has a lower water pressure than the roots, and that's going to draw water up from the roots to replace that water in the leaf that evaporated. So in the diagram here, we can see the water that's in the ground will be drawn up the roots, up the stem, and to the leaves because we have a low water pressure in the leaves as they open their stomata and allow the sun's energy to cause some transpiration. So again, as a summary, transpiration is the process of a plant drawing water up from the ground via its roots by allowing some of the water in its leaves to evaporate. Now we have a concept called evapotranspiration. And evapotranspiration is just a way to add up the total amount of water leaving an ecosystem by both transpiration and evaporation. So if we look at the diagram, the water that evaporates from the soil or from bodies of water, combined with the water that leaves plant stomata via transpiration, would be considered evapotranspiration. Really important to remember that both processes are driven by the sun. So when the sun's rays strike the soil, some of the moisture in that soil will be heated up and it will evaporate as a gas into the atmosphere. And same thing with the leaf. When the leaf has its leaves warmed by the sun and it opens its stomata, some of the liquid water in that leaf will evaporate as a gas. And again, that's how the leaf is going to actually draw more water up from the roots. And finally, we'll talk about runoff and infiltration. So when precipitation falls to Earth's surface, it can do one of two things. It can either flow across the surface until it reaches a body of water as runoff, or it can slowly trickle into underground water stores called aquifers, and we call that process infiltration. So we can look at the diagram here and we can see that if the water hits Earth's surface and just flows into a body of water, we'd call that surface runoff. But if it hits the ground and is able to soak into the ground and eventually reach an aquifer or an underground water storage, we would call that infiltration. Now, these two processes are very important because they contribute water to very important freshwater reservoirs. So runoff will recharge surface bodies of water, which are important drinking sources for humans and important sources for agriculture, but they'll also recharge groundwater, which can be especially important water sources in dry areas where humans have to use a well to draw up water from the ground. So remember that precipitation is going to recharge groundwater only if that water falling can infiltrate the soil. So if we look at this diagram here to help us understand that, if we have a surface that is covered by grass and soil, that's going to allow a lot of the water to infiltrate or to soak into the ground and recharge those aquifers underground. But on the right-hand diagram, we have a surface that's not very permeable, meaning it doesn't allow water to easily trickle through. And so far more of that water is going to leave the area as runoff. So permeability, or the ability of a ground cover to allow water to soak through and into the aquifers beneath it, is really important for groundwater recharge. Runoff, on the other hand, is going to eventually recharge surface waters. It will return water that fell as precipitation to a lake or a river or a pond, and that's an important source for humans to use. But one drawback of this is that the runoff gathers pollutants on its way to the surface body of water. And so we'll be talking about these issues in a lot more depth when we get to our water unit later in the year. Our practice FRQ for topic 1.7 today will cover the skill of explaining relationships between concepts in a visual model. So what I want you to do is take a look at this diagram of the water cycle. And there are 4 different letters. You have A, B, C, and D. I want you to choose one of those letters and identify the process that's being shown. Then describe how water is moving from one reservoir to another reservoir by that process. All right, everybody. Thanks for tuning in today. Don't forget to like this video if it was helpful. Subscribe for future APES video updates.
Alrighty. So what we want to do, I'm gonna stop sharing for a minute. All right, I want you to make sure that you understand the cycle. And again, this is a more complicated cycle than you're used to looking at the water cycle with just evaporation. Oh gosh. Transpiration and and what did I leave out? Condensation. Okay, so you want to make sure that you can identify all of those, but also be able to include. So when he talks about reservoirs, know what he means by reservoirs, with the where you have bodies of water stored up. My thing timed out, so I'm trying to get back to the module to pull up the diagram. All right. And then if you hadn't noticed, the topics in Canvas coincide with the topics in the AP classroom as well. So this is still 1.7. So I got it now. Come back. And I want you to see how this one is slightly more complicated than the one he just showed, but that's in the FRQ. So you are going to use that to identify the problem. All right. So if you're looking at this cycle, again, your basic cycle in the middle is evaporation, condensation, precipitation. The issue comes, evaporation is kind of straightforward. You have the ocean, you have lakes and streams, and those are places that water can evaporate from. You have surface water, water that's just lying on the surface. So those are your sources where evaporation can occur. And I say this because, give 1 second. Someone's coming. Okay. All right. So again, looking at this, and I'm on the right-hand side, I'm looking at the word evaporation in the diagram. And you need to remember your storage areas. So there's going to be the ocean, but not just the ocean. It's going to be rivers, lakes, streams, and maybe water that's puddling on the surface. So those are your storage areas, and that's where water can evaporate. The other thing he said that was important is the sun drives this. It doesn't just evaporate. The sun's energy dries it up, changes it from liquid water to water vapor. And then once it gets in the clouds, your next step that you're used to is condensation. And condensation means that it's going to change that water vapor into a liquid. And then we have the other word that you're used to is precipitation. But notice all these other words in between. So like I said, you're used to evaporation, condensation, precipitation, but now we're including so much more. So you need to know the word reservoir, again, where the water came from, the storage areas as reservoir. Precipitation, once it comes back to the earth, it can, one, come down. Precipitation can be rain, hail, sleet, snow. So there's different forms of precipitation depending on the temperature. There's also different places it can go. So this is where our runoff situation. So it can run off down the land back into a body of water. It can be infiltrated, like soaked into the soil. And once it's infiltrated, so that's another vocabulary word you need to know, infiltration. Once it's infiltrated, then it can go a couple of places as well. Could be a pathway directly to another lake, river, or stream. So if you look at this arrow, it's showing you a spring, a freshwater storage area, or back into the ocean, or it can go deep underground into what we call aquifers, storage areas underground. And most people who live out from a water source that have wells, this is where they get their water from. They're somehow connected to an underground aquifer, and that provides the water for wells. Okay. All right. So study this. You also have that word sublimation up here at the top. And sublimation means that at the very top where it's very cold, it bypasses evaporation and it goes straight from being liquid water to solid water. Sorry, it skips, goes from solid straight to being, so up here are the ice caps. Sublimation goes from solid straight to being a water vapor. It doesn't melt, it doesn't become liquid. It goes from solid ice to gas ice. So that's sublimation. He mentioned evapotranspiration. We perspire. So when water leaves our body, we perspire. When water leaves a plant, they transpire. Okay, but basically it means the same thing, that the plant is releasing water from its surface. All right, so again, study this diagram. Again, I'm in Canvas under water cycle 1.7. So study this diagram, do another read through on this passage, and then if you haven't done the AP Classroom, go ahead and do that. Okay. But everything he mentioned, he mentioned in the video is mentioned here. But in particular, to answer the FRQ question, you need to go ahead and study this. Even though his question just wants you to pick one of the cycles and then explain what happens from there, you still need to know the whole cycle so that you can understand where it's going, because that's why it's a cycle. While you're starting it, you're picking a starting point. It could be anywhere. Okay, it could be evaporation, start from there. You could be starting from precipitation. You could be starting from condensation. Then you need to talk about where it's going from there. That's how that question is. So it's labeled A, B, C, and D. Pick one, and then just name it, and then explain the passageway from there. All right, so I'm going to stop talking, take attendance, and then let you catch up on what you need to catch up on. So again, right now I'm looking at 1.6 is phosphorus, 1.7 is water. Both of those have been assigned in the AP Classroom. Like I said, most of you have done it. Some of you have done one and not the other. So please check to see which one you have not done and make sure those are done. Again, everything needs to be done by October the 3rd, because that's when this 9 weeks gradebook will close. So I need to get all of these assigned in by then. I have not put a column for 1.6 and 7 in the gradebook yet, but I will today, as well as the FRQ for 1.6 and 1.7. Any questions? Any questions? All righty. These things keep in AP classroom times out on me so quickly. And just a heads up too that the progress check is the exam, and I will probably end up taking out. So the exam is all on unit 1. The first 9-week exam is unit 1, all of unit 1, except I might take out questions that are food chain and food web. We will probably get to productivity and trophic levels and energy flow, but we may not. I tell you what, I won't, because energy flow goes with food chains and food webs. So we'll just get to trophic levels. So next week we're going to, or starting next class, we'll start on productivity and trophic levels, and we'll let those be the last 2 units that we try to do with this 9 weeks. I'll save the other 2, and also I'll take off any questions that have to do with the 10% rule and food chains, because they go together. Okay. All right. So again, everybody is catching up on they need to catch up on. I'll let you know as soon as the FRQ question is up, because I know some of you are finished with both and you have nothing else to do, but you can review. You can review. So we started off with introduction to ecosystems, terrestrial biomes, and then we went from that to aquatic biomes, and then we went from that to our 4 cycles, our carbon cycle, nitrogen cycle, phosphorus, and water. Okay, that's a lot of cycles. So take the time to review those if you are finished with everything else, because there are written questions on the exam pertaining to those cycles. Take a look at the pictures of the cycles again and make sure that you are familiar with all the stages of each cycle. All right. Attendance first, FRQ next. Mm. Authorize. Danny, and I'll let you know when I check it. Okay. And I guess that's excused, or I guess I shouldn't be marking. I'll take it off. Okay, I got you. I did write that down, but um I don't know whether they excuse it or just not supposed to mark it at all. I'm gonna ask that question. Let me take that out. Oops. Okay. Fixed. Undone it. Amelia, I will check. I don't know about undone, but I will see what you mean by that. Anyway. Okay, so the FRQs are now assigned. And they are just as he said. All right, so the first one, and each one is worth 3 points. On the first one is dealing with the phosphorus cycle. And the second one is dealing with the water cycle. And the first one, you want to choose 2 reservoirs. So that means 2 places where phosphorus is stored up. And it's 2 reservoirs depicted in the diagram. So you got to study the diagram. And then describe how it moves from one. And remember, this is a cycle. So look at your cycles and discuss how it moves from one point in the cycle to another. Same thing with the water one. It says, like he said, A, B, C, and D labels on it. You're going to choose one of the processes in the diagram. So mention the letter that you pick as well as what name the process, identify that process, and then describe how water moves from that point to the rest of the cycle. Okay. All right. So that if you don't see it, it's refresh your page because again, I just put it there. But it is on your to-do list. So go to your to-do list, click on that, and it should take you to the FRQs. All right. So for some of you, this is the thing you're doing now. Some of you got a lot to catching up to do. Again, please try to get it all caught up, preferably before the week is out. All righty. Now, let me see which person. Okay. Okay. And I think. Hmm. And I've got 1, 2, 3, 4, 5, 6 of you who, it's nice that everybody's present today. So please also go back and look at the nitrogen gizmo. Some of you did not, and I'm going to go back and check too. Some of you did not complete the all of the activities, so you did not have a complete score. You don't have I couldn't grade it because you hadn't completed it. You've got to complete it. All right, and we have to talk about oxidation and reduction as far as the nitrogen cycle is concerned, but we'll do that tomorrow. Because on the worksheet, that's the only place where some of you got tripped up in your answer. Okay. Okay, Abigail, Gianna, and Kayla. Y'all are the only ones who have not completed your Gizmo activity. Abigail, you haven't started. You might have done the worksheet. Folks, there were two parts to this. You had to do the worksheet and there were activities that you had to do as you went through the gizmo. And you had to answer all of the questions all the way to the end because the last one is a summary question. Yeah, the worksheet is only part of it. And so if I graded just on the worksheet, that's like a third of the grade. So you got to go in and do the gizmo and answer the questions. So I haven't graded the worksheet because I'm waiting on your gizmo score. No, not the one I'm looking at. I'm looking at it says, eh, can you screenshot yours? Because it's showing me, it's not showing me that you have not started it. Every area says no response. There's 15 questions that you have to go through. The last one is a case study. But even if it puts you back to the beginning, it should have scored something. All right, hold on. I'm gonna look. Give me a second. Okay. Yeah, it might have. Oh, I'm looking at the wrong person. Okay. Actually, yours won't load for me. Trying to look at your screen, but yours is still loading. And you followed all the little boxes that said next, 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 and answered the questions in between. Like I said, for some reason, Go Guardian won't, it's still loading you. I don't know why, you're the only one. Everybody else is loaded. Hmm. All right, and again, if you are finished with everything else, you should be working on the FRQs. All right, Jen, I don't know what, in Go Guardian, your screen is loading. I don't know why it's not loading. It's just loading, spinning around and round. Let me see something else while it's doing that. Let me. Yeah, I'm not sure either. Like I said, yours is the only one that's not not loaded. I got everybody else up. I can see everybody else. It actually has actually two things. I think you haven't answered all of the question, and that might be why it took you back to the beginning. Because it looks like there's two things that you attempted. You didn't answer them all the way. So you might have to start at the beginning again. I know. So I don't understand. And you moved all the way to, it won't let you do it again? Mm, I don't know what to say about that. Because it is, oh, wait a second. All right, now I'm clicking on different places. Okay, so I can see. Um, I see responses all the way up to question 8. So if you could go in, where am I? And after that, there's nothing. Um, if you could possibly go in And hold on, let me add this up first. All right. Um, this is what I'm going to do. I can go in and reset you. Yours won't be late, but the only way I can fix this is to reset it. Okay. Oh, now I see. Okay, now that I've done a couple of things, now the things are showing up. Okay. But it's still, you didn't finish it. So I don't want to reset the whole thing. It should let you, starting with question 9. Using what you've learned about nitrogen cycle, what do you predict are the oxygen levels on the river? So let's see where that is on the, so it's really starting you from question 9. From question 9 on, there are no answers. So let me pull up the case study, see if I can't get to that point. Oh, let's see if you've loaded yet. Nope, you're still not loading. Don't know why. All right. Let's see. Okay, that's not the question. Yeah. It's hard for me to tell where that question starts. But go to the handbook, Gianna, and start with nitrification. And I think that's where your question starts. Because I think from there on, you might have done the case study and gotten through the conclusions. But you haven't done the case study. The case study should let you answer it. But don't do the case study until it says you answered the case study question. I wish your page would stop cycling so I could see. All right, you answered the handbook, but now you need to go to the part that says oh, goodness. Because you can't get through these. All right, after you've done the handbook, did you return back to, because it says when you complete the handbook, it return back to the case. And then look at the conclusion. The last thing the handbook says is return back to case. Okay, go back to, because that's the part, yeah, that's the part that's missing. So go back to case and you should be at data collection. That's where it is. I was trying to figure out where that question was. Okay, thank you. I'm glad we figured that out. Alrighty. Emily, you said you've done yours, so let me check you, Emily. Sorry, Amelia. I don't know why I want to say Emily all the time. Amelia. Okay. All right, so there's three of you still working on it. Please let me know so that I can go back into the gizmo to collect your scores. Mm, it's giving me such a that's a simulation. Oh, bless your heart. Okay, folks, it is 1:30. You are free to go, and I'll see you tomorrow. I'm going to stay logged in because this is tutorial time. People will be logging in, but I don't want to log out and log back in case they're waiting. If you wish to continue working, all right, go ahead, stay logged in. Other than that, you may go.